All right, hey there everyone. I'm James Daniels. I'm a developer relations engineer on the Firebase team. This is the first time I've traveled since COVID, so as you can see, I'm a little rusty at this. So let's see if I can hit my stride. Since I've not been going to a lot of conferences, and some of you have already harassed me, clearly not spending a lot of time on Angular Fire these days, I'll let you know what I've been up to. I've been embedding deeply with the Firebase app hosting team, making sure that they're building the right product for the next generation of web application hosting on Google Cloud. So we have first-class support for Angular, Next.js, and all applications powered by Nitro. And of course, it's built on top of build packs. So there is the fallback to Node.js. So I've been doing a lot of that work, working closely with product and engineering. And that product just went GA. So I'm starting to pop my head back up and meet with developers and talk about things. So Firebase app hosting is for multi-page applications, right? We had Firebase hosting before, which was very geared towards single-page applications, static web apps. But this is geared towards multi-page apps. Basically, right, I liked how it was put by the React team, where you have someone else's computer and then your computer as the end user, and all the stuff that we call SSR, SSG, is someone else's computer. I like to be on the bleeding edge of technology. So back in 2017, I actually was the first person to get the Firebase SDKs wired up in Angular SSR. And while I'm not going to give a live demo on stage today, I did then, and it went all right, as well as can be expected with Zone.js issues and the things that we had to deal with at the time. But a lot has changed, right? It's been 8 years. So we have isomorphic JavaScript. It's now widely adopted across JavaScript frameworks. I have to do a lot less explaining what SSR is, what SSG is, and why those matter. The hybrid rendering strategies are catching on, resumable APIs, and of course, Angular's been making a lot of improvements, and we have incremental rehydration, which I love. And all of this allows the developer to realize the benefits of SSR, right? It's one thing to wire in Angular SSR. It's another thing to make your application performant, to make it cost less, because you are adding a lot of complexity, a lot of cost, and needing a server. So all these together, right, make it so that developers can realize this. But not everything's rosy, right? We've taken a lot of complexity on in our applications now that it's not a single-page app that we just throw on a CDN, right? We have to manage a server. We have to communicate with the backend engineers who are like, you're using JavaScript to do what? Node.js, is that allowed here? So cost and complexity are hard. And of course now, like, we're getting spammed by bots all the time. We now have LLM agents putting load on our servers. And we have Web Application Firewalls, which can help there, but they're hard to configure. They're a black box, and is it tailored towards your application, right? Or is it trying to protect a WordPress site? So, tailoring towards Angular and your specific application. CDNs, right? Firebase hosting, we had a good CDN there. We're trying to go Google Cloud TOS, so admittedly, Google Cloud CDN it's a little old, right? It's that older generation of CDNs, but it's very great for that cloud TOS and all those things that your CISO cares about. So are they keeping up with the times, right? Do they support stale while revalidate, stale while error? Like all these newer cache control headers, are they there? That can be difficulty. And then once you do get your application up and running, very likely you have a lot of vendor-specific stuff, right? You have things that make it work on Firebase, right? You have our config files, or you have Netlify or Cloudflare configuration, things that only work in those ecosystems. So you can get locked in, which isn't great. I did server rendering before. I came from the LAMP stack and then Ruby on Rails. So whenever I was educating people there, I would joke that server rendering's a tower defense game, right? Has anyone played tower defense games where you have to keep the enemies from overwhelming your castle? So you build turrets and walls and stuff like that. And with web requests, it's much the same. You want to bounce the request early, right? You want to either serve the request or reject the request, right? Or redirect it to something more efficient. And ultimately, you're protecting your server, right? For us, that would be your Node.js application, which is deep in your data center. It's expensive to run. It has access to all the things. So if it gets pwned, so does your database. So defend the castle. So Edge is hot, right? Edge computes. What exactly is edge compute? There's a lot of marketing around this. And traditionally, edge compute was devices on the field, right? So if you had sensor platforms, IoT, that sort of thing, that was edge. The bigger providers that have a little bit more money to play with, the stuff on the POP node on your ISP. So when you make a request to YouTube or Netflix or something like that, there's going to be a blade server on the CDN, before the CDN on the POP edge, before it even enters our infrastructure, and popular content will be served there. So that was edge, but not many of us can afford those kind of toys. So then the CDNs started making their own edge products, right? A lot of these are powered by V8 isolates. So the V8 engine that powers Node.js and others and Chrome. There's actually an isolate mode. So it's basically a service worker. And some very ambitious engineers were like, how can we use this for edge computes for our CDN so we can have a higher CDN hit rate? So very cool. But the industry is moving towards something, and that's WebAssembly. It's been promised for a long time. You might hear a lot of the C++ engineers going on about how, we don't have to ever think about JavaScript again. And that's not how this is playing out, right? So what is a WebAssembly? If you're not familiar, it's a binary instruction. It's assembly for a stack-based virtual machine. V8 can run them. And it works in the browser, right? So you can load it on the side. You can do intensive tasks. You could write a program in C and compile it and run it in a worker in your browser. So it's really good for things like messing with images or doing expensive operations or porting a large code base that you have. But the real benefit of it, I think, is the sandbox, right? So it is strictly sandboxed. It's a ABI that has been accepted by multiple providers. It's been adopted into cloud native, so it works in that stack. And you don't have to do the sort of YOLO run, V8 isolates with a service worker API on the edge thing. So this is much more accepted technology that the graybeard engineers that are scoffing at Node.js in your organization will accept. Yeah, it can be built C++, Rust, Golang, assembly script if you want something a little bit more TypeScript flavored. That list is growing, like what has compiler targets for it. I'm partial to assembly script and Rust myself, but I do know a lot of Golang fans working at Google. So you can move those native workloads, the C, C++ code. But I think the more powerful thing is the APIs, right? So you can have a contract that implements a proxy. So proxy WASM is an API that allows you to have reverse proxy semantics anywhere WASM is supported. So you can plug these into a lot of different providers right now. What does this look like? I threw up some assembly script right here. So you can intercept the request headers, response headers, the body, right? And the basic actions that you have is you can stop the request, you can pause it, you can respond, or you can kick off a side request. Those are the major semantics of it. So here, I'm just logging something, hello world, I got a request coming in, I'm going to let it continue. Or I could pause it, so I could tell it to stop, and then I can dispatch an API call. Maybe I want to get some data, maybe I want to verify the user. I don't have to dispatch something. This could be running native code, so I could be cracking open the JOT and checking if this user's who they say they are before allowing them to continue the request. So here I pause the request, let the background operation complete. Once that background operation is complete, I can do something with it, and then I can say, resume the HTTP request. So very simple semantics. This API, of course, anything that targets WASM can build it. So assembly script, Rust, C, C++, you name it. So once you have this WASM proxy, where can you deploy it, right? You can, of course, set it next to your application, right? So it can be on your server or a sidecar on your server. Or it can be in your reverse proxy layer, right? It could be in your application's data plane. So you could use something like Envoy or Nginx, right? Then, of course, your load balancer can take these. The CDN can take them before and after it hits the cache. Some providers do allow you to take these all the way to the POP edge. So if you're willing to spend a lot of money, you too can get the benefits of like having something running as close to your customer down the street, right? Like at that corner location that your ISP runs, you can have compute there. Very, very restricted in time and resources. And of course, you can run all this on client side, right? You can run it in the browser, in a worker. You could run it in a CLI app, a Node.js app. So basically, you have this WASM module, and you can just throw it anywhere in the architecture. So this is a quick grab from the Edge Compute docs over in Google Cloud. And here you can see there's a lot of different names, because Google loves lots of names for things. So edge extensions, traffic extensions, authorization extensions, they're all the same thing. It's a proxy WASM module, just sitting in different parts of your stack. So you get a WASM module, you get a WASM module, you get a WASM module, everyone gets WASM modules. So what can we do with them? I mentioned porting large applications, native code that you already have, expensive operations, right? So things that JavaScript and Node.js are not particularly good at, right? Image optimization being a good one, generating your open graph images, right? Node.js performs fine there. It's probably all right for your dev server. But once you're up in production, that's just very inefficient and costly for you, right? So doing medium processing, you can put thumbnails on images, you can resize things, you can change the format of media to adapt for the agent. Compression, you can actually get a pretty significant speed up on your Node.js applications if you just, whatever server you're doing, you just turn off compression and then do it in your data plane outside of Node.js. You don't need a full operating system for that. You don't need to do that in JavaScript, and it's kind of slow. So side benefit on Google Cloud, if you turn off compression, you can accept H2C, so you can get HTTP2 all throughout your data plane. Data enrichment and input validation, right? So you could reject some requests. Maybe you're getting spam. Maybe you have an old version of a form somewhere getting submitted, right? Like something's posting data that's bad. You can reject it. You can transform it. And you can validate it before it gets down to your server and costs you money. Security, right? So we can do auth N and Z on the edge, right? So we can crack open the cookie or the JOT. Preferably, this is stateless, especially the further you get from your data center, the less possible and less realistic it is that you're actually going to be able to make an HTTP request, right? So stateless is great. Use JWTs. You can crack them open. Check it out. You can do some basic rate limiting. You can do some advanced rate limiting if you have some durable storage, a key value store, along with your edge compute. Some frameworks have concepts like middleware. You can, of course, if you're doing microservices and stuff like that, on the edge, filter out all your magic headers. So your X vendor magic header that allows your microservices to coordinate. You can filter those out on the edge before they get into your data center and you get hacked, right? Because someone figures out your magic headers. And of course, you can do data loss protection, so you could scan outgoing requests, right? You could look at the response data and make sure people weren't exfiltrating things. So you could put, things in place there to do some of that. Good methods for cost control. So a pattern that I really like to do at Google, when we spin up internal services on Cloud Run or Cloud Functions, we have severe quotas, right? We have to go hunting for quota because these are just meant to be demos, right? I'm sure a lot of organizations have policies that say, oh, you can't have more than 4 gigs of RAM on your instances without permission, and they're rate limited. So the typical bot crawler stuff, if it's 404ing, it's not hitting the CDN, right? So it's triggering Node.js, and you can exhaust your quota really quickly. So a pattern I like to do is have a piece of WASM code behind the CDN before my server that says if the CDN missed and this user doesn't have a valid authorization header, just respond with a 404 before it goes all the way down to my server. A novel approach could be to actually take your Angular routes, just the glob pattern, and send that up and do the same thing. 404 early before it hits Node.js, and it costs you money and quota. Expensive endpoints, right? You could restrict access, again, auth NZ, rate limits. So maybe you had an API endpoint that had a GPU attached that you were running a local LLM on. You could restrict the access before it ends up costing you those CPU seconds. And simple things like preventing hot links from your images. Request routing, another big bucket. So rewrites. So we can take requests, we can put them to different servers. Maybe you're using microservices, maybe you're using a monolith as a microservice where you have your Angular code base with SSR, and you just have different API endpoints that you want to scale differently. So that's a good reason to use rewrites between the servers. And of course, why even take the cost if you're serving an immutable asset? You can just serve that from a GCS bucket. Redirects I18N and microservices. So, right, stateless is great. As you get closer and closer to your server, maybe you have the permission to start making API requests. You're willing to take that wall time to prevent your node server from being hit. But, right, it's anything you don't need a full operating system with, file system, things of that nature. With WASM, there are some standards coming to, have file I/O and more things closer to an operating system. But that's all emerging stuff, and I'd steer clear of it if this is just about protecting your server and reducing cost and load. So, quick fire. I'm a little bit of a mad scientist, right? I like to play on the edge. I've been experimenting with a lot of things. Some of these are things that I had to modify Angular for. Some of these are things that are barely working that I just have a proof of concept with. So here be dragons. So we have novel rendering strategies. Incremental static regeneration. This is SWE, SWR on steroids. So it got popularized by Next.js, but what you do is you serve the stale content from your CDN, and then you regenerate it. So it's basically SSG on demand, where you regenerate it and then push it back up to the CDN. So you're kind of letting crawlers and people navigating your site kind of cause lazy SSG. So really, really good for performance. Touched on this a little bit, but different strategies depending on where you are in the OCI layers and the auth state and headers and cookies. But yeah, rejecting on CDN miss if unauthenticated. Transforming the request response, so you could add content to it, right? So you could add headers, you could munge the HTML, a little gross, but you can do some interesting things there. But what I like to use it more for is, I mentioned the CDNs sometimes, they don't support certain things, right? Like if you make a request with a cookie and you respond with a set header, right? Or you're setting a cookie, then pretty much every CDN says, I'm not going to cache that, right? So what if you wanted a set header that was CDN friendly? You could actually munge that. You could transform it into an X namespace set header before it hits the CDN, and then after you could transform it back into a set header. So using magic headers for stuff. And you could also rewrite URLs just to be CDN friendly, right? Because maybe the cache key mechanism, you couldn't quite get it to do what you wanted to do. Partial pre-rendering and islands is a strategy that like Next.js and Astro popularized. Basically think of it like the Angular's application shell, but it's personalized for the user, right? So you make a request and you will see the HTML shell for you, personalized with your auth state and stuff like that into account. So good for sidebars, and then things kind of populate as those async promises finish on the server. So React has, this touches on it, React postpone, resume, and dynamic I/O. So this is a really crazy one. There's no concept quite like it in Angular. I've hacked a couple things together just for fun, but I had to get it, we support Next.js, so I had to get it working on Google Cloud. So how this works is whenever an async boundary or a file I/O boundary is hit in Next.js, the rendering pauses, the HTML is sent to the client, and then you get a token which allows you to resume the render. And you can pass it to the renderer again, and it'll create another HTML chunk until it hits another async boundary. And then to the user, what that looks like is you're stitching those requests together. So they have a first load that's CDN cacheable with no personalized content. And then the HTTP stream starts trickling in the updates to the DOM out of order, which is really cool. I played around, I hacked a couple things to make Angular do something similar, but it is far, far, far from anything that I'm even willing to write a proposal for. But it's just fun stuff. And then, sharing code. I mentioned that these can run anywhere, right? A lot of place in the OCI stack. So maybe you could do something novel like, what if your router guards, right? Router guards aren't really secure. It's just for client-side navigation. What if your router guards did actually protect your content, right? A router guard ran on edge compute in front of the CDN, and even if it was statically cached content or SSG content, it would get protected by that router guard. So I played around with that. It's kind of working. It's horrible, but and it's powered by JS runtimes and WASM. So this is a bleeding edge thing. There are a couple novel JavaScript runtimes that you can run inside of WASM. I was playing around with Boa, which is a Rust version of a JS runtime. All these are around 70 to 80% of the ECMAScript spec are passing. So they're not ready for prime time, but it's fun to experiment with. And for organizations that don't allow Node.js internally, like Google, this could actually allow for server-side rendering or something like it, a light version of server-side rendering in organizations where Node.js is not an allowed runtime. So might be worth exploring. If you're interested in playing around with WASM on Google Cloud, pushing stuff to the pop edge in front of your CDN, you can get started with service extensions, cloudgoogle.com service extensions. And yeah, this is just, WASM's cool, it's bleeding edge, it's getting there, it's usable now. There's some cool things that it might be able to do in the future. But this is a technology that has finally started being able to make an impact in your code and reducing load on your server. So we have LLMs, right? Things are changing in this space. An LLM can generate code. If used well, it's going to be an abstraction layer. So every time we've gotten a new abstraction, right, what we considered our application code, the code that we were writing as app devs, grew, right? We got GraphQL, so now it wasn't the DBA's problem. We got SSR, we got in the business of servers, right? So kind of how I'm challenging people is look at LLMs as an opportunity to, instead of worrying too much about making buttons and components, think higher level. Start solving problems that maybe you were like, that's someone else's problem. That's my data plane guy, right? So that's why I've gotten into WASM and really enjoy it. I'd be really remiss, Firebase sent me here to talk to y'all. So Firebase is Google's app development platform. We have some new products. We have GenKit for doing Gen AI stuff. That's not actually like a Firebase product. It's just an open source library that's trending on GitHub. It's really awesome to build agent workflows. We have Firebase app hosting, which is our new SSR stuff. We don't have WASM in our data plane yet, but we're thinking about it. And of course, Data Connect, which is a SQL database offering provided by Firebase, which has been asked for many times. So thank you very much. I'll be around if you have questions.